Yes, I think we are live right now. Great. Hey, folks, welcome to the online edition of GraphQL Bangalore Meetup. This is the first online edition after this COVID situation. Um, I think the last meetup was in January, this in Bangalore. And we had like three talks over there. And yeah, it's exciting to be back online. We have two speakers today, a couple of talks. One from Nader David from AWS. He's going to talk about transforming GraphQL. And the second talk will be from Ashwin. He's from Swiggy. And he'll be talking about building a chat app, like a WhatsApp app, using GraphQL subscriptions and Flutter streams. So yeah, pretty exciting. Um, so a little bit about ourselves, the organizers. I am Praveen, developer advocate at Hasura. You can follow me on Twitter, GitHub, the handle Praveen Web. We have Karthik in the stream. He's the next dgraph US developer advocate over there, and you can follow him on Twitter and GitHub. Karthik, do you want to introduce yourself? I think Karthik is muted. Um, hey, Karthik, I think you're muted. All right. So till Karthik figures this situation, you can also like follow us on Twitter, GraphQL Bangalore. We have a Slack channel in the GraphQL Slack. There's a GraphQL Bangalore channel where you can like post questions and discuss for about upcoming meetups. Also, during the talks, if you have any questions for speakers, you can post a comment on the YouTube chat, or if you want to catch up async, you can post a question on the Slack channel, and the speakers will be answering to that asynchronously. Um, right.
Yeah.
So if
Yeah.
yeah,
Can you guys hear me now? Okay. Hey, Karthik here. Again, welcome to the sixth edition and our first ever online edition of the meetup. And follow me at the rate hack into SHRAV. And as Praveen mentioned, feel free to drop in your questions or queries or any interactions you want to do with the speakers right at the chat window. So, Praveen, should we get started?
yeah. So our first speaker is Nader David. I'm just going to add Nader to the stream. Hey Nader, what's up?
Hello, hello.
Yeah. How's it going?
I'm doing very good. How about yourself?
Yeah, I'm great. Yeah, I believe it's morning over there. I hope you had your breakfast, already charged up.
Oh yeah, I'm ready to go. It's 9:30 a.m. here. I'm in Mississippi in the central time zone in the United States. I'm definitely energized. I'm on my second cup of coffee.
Awesome. All right. So over to you, Neda. You can start presenting yourself.
Okay, great. Yeah. So I guess I'll go ahead and um, share my screen. All right. Okay, so I just need to choose the proper screen. And can you see my screen? Is that okay? Just making sure everyone can see. Um, yeah, can you give me confirmation if you can see my screen, please?
Hey, I can see your screen. Yes.
Okay, cool. I just wanted to make sure before I started going. Okay, cool. All right, so I'll go ahead and try to make this a lot bigger because I know my screen is pretty big. It's kind of wide, so it might be a smaller resolution. I've tried to make everything as big as possible. So yeah, thank you so much for having me. I really, am honored to be here. I wish I could be here in person. And if this was a typical year, I may have actually been there in person. I did travel to India last year, and this year I was supposed to go back. So none of that travel, of course, is happening, but I had a really great time there and was planning kind of like a 3-city, kind of like a tour, I guess you could call it, doing a bunch of events. I was going to be there for like 10 days. None of that happened. But I'm really glad to be here virtually, and hopefully next year we can do this in person or something like that. But and then second of all, I just want to thank you for taking the time out of your schedule, your day. Everyone has a lot of stuff going on to kind of attend this talk, and hopefully you can learn a lot from it. So this talk is, focused on a combination of GraphQL and serverless cloud development, and it's called Transforming GraphQL Full Stack Cloud for Front-End Developers. Now, when I talk about full stack, when I talk about front end, I think what we're starting to see with a lot of the managed services that are out there, as they become more powerful, there's kind of like a blurred line between what is a front-end developer, what is a full stack developer, and if you understand how to kind of leverage these back-end technologies as a front-end developer, you're becoming a lot more powerful in your skill set, but you're also becoming a lot more valued in the market. You're able to make more money. You're able to provide more value for either yourself as a independent consultant, or if you're building your startup, or if you're hired at another company. If you know how to kind of leverage the, I guess, skill set that you have in a way to kind of let the employer know, what you're capable of. You can actually make quite a bit more money if you understand how to leverage a lot of these technologies, as well as being a competent front-end developer. So I'll walk through the talk. It's going to be an introduction to what the tooling that I'm going to be talking about is. I'm going to then kind of do a live demo of a rapid prototype. I'm also going to be showing off one live example, and then the main part, I guess, is like a combination of the second part, which is the data modeling piece, and then kind of rapidly prototyping an app or a backend based on that data modeling piece. So the data modeling is kind of taking the knowledge that you might already understand about GraphQL and applying another SDL to that schema. This schema definition language is called the GraphQL Transform Library, that we have kind of put on top of the typical GraphQL SDL. I guess you could call it, kind of like just an additional abstraction on top of what traditional GraphQL schema might look like. So my name is Nader Dabbit. I'm by trade a software engineer. I've focused on mobile and web development for the past 10 years, really focused on mobile development and cross-platform and React and stuff from 2015 until now. And then the last couple of years, I've been doing a lot of full stack cloud and full stack serverless development because I work for Amazon Web Services as a senior developer advocate. I do a lot of open source. I've open sourced a bunch of full stack reference architectures. I've created projects like React Native Elements and Jamstack CMS and Jamstack e-commerce. And I've written a couple of books. My most recent book is Full Stack Serverless, and it kind of goes into a lot of the stuff that I'm talking about today. And it's available from O'Reilly. It's called Modern, or the subtitle is Modern Application Development with React, AWS, and GraphQL. So the talk I'm giving today is kind of focused on AWS and GraphQL combined. Doesn't matter the front end framework that you use. So when you think of AWS, I think a lot of times people think of back-end technology or infrastructure or DevOps and those sorts of things. But in fact, my team has been growing substantially the past couple of years, and we're all front-end devs for the most part, or at least that's what our tooling is focused on. We do have a lot of back-end devs that are building tooling focused on front-end devs, but I think we all have to have an understanding, either as a front-end dev or kind of understand what the challenges are for front-end devs to kind of build the right tooling for those developers. So we're kind of like a true full stack team. And a few of the things that we're focused on, like there's like core tenets or philosophy around the work that we do. And the first one is around developer velocity. One of the key differentiators in the startup world today, really. And really, in any business area, really, when you think of it, when you think of how rapidly technology is changing and what you have to do to keep up, one of those things is being able to leverage technology in a way that allows you to do that. So one of the things that is a core piece of that is the developer velocity of your infrastructure, or the developer velocity of your engineering team, I guess you could say. Being able to rapidly build stuff, being able to try new things, and at the end of the day, being able to experiment. If you have an idea and you want to see if this idea works, would you rather spend 1 week building this, 1 month building it, 1 year, or longer, right? The faster, the better. Because if this idea doesn't work, you can trash it and try something new, or continue down maybe a small iteration on what you've already tried. So experimentation, developer velocity kind of go hand in hand. Also affordability. When you're talking about hiring developers today, the good developers, or just developers in general, just becoming a lot of times, more expensive. And especially here in the United States, if you go to Silicon Valley or even any of the bigger cities, a lot of the developers are making, $200,000-$300,000 a year, more than that even. A lot of the big mobile, the really solid mobile developers are asking even more than that. So for a startup to be able to come into the market and be able to compete on the level of a company that has $100 million in funding, or maybe a company that's already profitable, how can they compete? And I think one of the things is finding ways to be more efficient. And one of the ways that you can do that is with serverless technologies. With serverless technologies, you are not paying for the infrastructure unless it is being used. So you can build out an entire end-to-end, sophisticated, real-world application along the lines of something like a massive company, but you're not going to pay for any of that infrastructure unless you have customers. So therefore, you kind of are able to save the money that you typically would have spent there and use it elsewhere, or extend your runway as a startup. And then once you get customers, your compute bill starts going up. But once you have a lot of customers, that's usually a good sign, and you're able to get funding and things like that. The next thing that we're really focused on is lowering the barrier to entry. So in the past, I would say, especially for me, when I looked at AWS and cloud computing, I always thought of it as something that I would never understand or be able to do. But our team is focused on kind of building tooling that breaks that barrier to entry down and makes it easy for developers like myself, who was traditionally a front-end developer, to build on the same infrastructure that Netflix is building on, or that Uber, or all these big companies. How can we make that possible? And that's one of the things that we're focused on. And then because we're focused a lot of times on serverless technologies, or really just AWS, by default, you're going to get that scalability out of the box. So if you build an app and you can spend the same amount of time building this app, and it will scale to 10 users, or it will scale to 10 million users, or 100 million users, and you don't have to put any additional effort into scaling it to 10 million users, which way would you rather build? By default, in the past, we might have assumed that what we're building isn't going to scale. But what if you could use the same amount of effort and build something that is scalable? That is something that we are focused on enabling for developers. So if you do build something, you don't have to rewrite it once you get market validation. So, at the end of the day, we want to allow any developer, to be building on the same infrastructure that these massive companies, like Amazon and Nike, build on. So how can we do that? Well, one of the things that we are focused on doing are building really good abstractions on top of AWS. But we understand, again, that we're having there's just a massive number of developers that are not traditionally cloud computing developers, or cloud developers, or even backend developers that are interested in this stuff. So we're trying to bring out tooling that allows developers to use their existing skill set to build in the cloud. And the team that I work on, we have a couple of things that we build. We have Device Farm, we have AWS AppSync, we have a big Amplify console hosting service, and then we have the Amplify framework, which is kind of a combination of these three things. Excuse me. So we have AWS Amplify is kind of the main thing I'm going to be talking about today. It's a CLI for creating AWS services in CloudFormation, which is infrastructure as code. We have client libraries for Flutter, iOS, Android, web, React Native that allow you to then interact with those services. And then we have a static site hosting service that allows you to kind of have a one-click deploy either from GitHub or from your local project. So the CLI is what we're going to be looking at today. And this is where the GraphQL transform library kind of comes into play. But to understand how that works, we first need to kind of go over the configuration and initialization process. Because if you want to use the GraphQL transform library, you're going to be using the AWS AppSync GraphQL as a service, which is kind of one of the things that you can spin up with Amplify. So to create a new service, you just run Amplify add and then the name of the category. So for instance, if you want a REST or a GraphQL API, you would choose API and we would walk you through a bunch of steps. If you wanted to add image storage like S3, or if you wanted to add authentication, whatever, you just run Amplify add. And then when you're ready to deploy any changes, you run Amplify push. Amplify push takes the local CloudFormation infrastructure as code and deploys that to the cloud for you. And then you can make updates locally by running Amplify update. And at the end of the day, what you end up with is this idea of full stack cloud. So we build the cloud infrastructure, but we also do a lot of things on the client. So for instance, if you're if you're using GraphQL and you need queries, mutations, and subscription definitions based on your GraphQL schema, we do GraphQL code generation. We introspect your GraphQL schema and we build all of those definitions for you. And then you can just import those into your project. And we do this for all of the clients that we support. So we do this for iOS, we do this for Android, we do this for web. And then once you've created your service, we have a couple of GraphQL clients that you can work with that work especially well with the AppSync service, or you can use something like Apollo or Urkel. But for our circumstances for this example, we have an API or GraphQL client. And the API GraphQL client allows you to call api.graphql, and you pass in a query, a mutation, or a subscription. And then you can also pass in variables and things like that, or you can pass in your own headers, whatever you'd like. But by default, we're going to actually sign the requests for you using using the proper headers based on your configuration of your app. So if you have authentication enabled, we're automatically going to include in the headers the ID token for the signed in user. You can also specify type of authorization. So you can have public authorization. You can have a few different types of authorization. And then, like I mentioned earlier, we automatically generate the GraphQL queries, mutations, and subscriptions. So you just include whatever operation you want in the query field there. And some of the categories that we currently support in addition to API are authentication, storage, machine learning with predictions, functions, hosting, and interactions. But the one we're going to be focusing on today is GraphQL. So one of the things that we have built into the CLI is different types of tooling. And the one we're looking at again today is the GraphQL transform library. So let's take a look at a typical GraphQL API. If you built a GraphQL API from scratch, then you probably know how much work is involved. And I think I just saw a tweet from someone like a few days ago, Harry Wolf. He created a YouTube video kind of just complaining about how difficult it is to build a GraphQL API on the server and make it scale and do everything right around authentication and authorization. And he's absolutely right. If you've ever used something like Hasura, 8base, AppSync, or any of these other managed services, they're very powerful because they abstract away all of this stuff for you. So for a GraphQL API, now all you have to worry about is kind of creating your schema, and then everything else is essentially done for you. And that's the case with AppSync. So when you build a GraphQL API, you have to create your schema. You have to have all of the different definitions and operations like queries, mutations, and subscriptions. You have to have your data sources. So you have to have your databases, whatever operations that are connected to your operations in your schema. Those need to be connected to some data source. And then you have to write the resolvers, which is really one of the areas that people I think have a lot of frustration with when they're getting started, because just to get started, you have to kind of understand quite a bit here in writing resolvers from scratch. But what the GraphQL transform library does is it basically abstracts away a lot of this for you. So all you have to do is create your GraphQL schema with only the types. You use the GraphQL transform directives, add them to your schema, and we essentially kind of run a build. And this build creates infrastructure as code, and then you can deploy that to the cloud. And you have complete control over everything. It's a managed service, but you have complete control over your resolvers. So like we automatically will build out a lot of logic for you there, but you also have the option to go in and write your own custom business logic, because really all that's happening in the resolvers, they're just functions. And in those functions, we're automatically going to make assumptions at the beginning, and then you can kind of take those and make those have whatever business logic that you need for your app. So some of the transforms that we're going to go over today are listed at the top, but these are all the ones that we support today. So @auth allows you to add authorization rules. Connection allows you to create many to one, one to many, and many to many relationships. And a bunch of other stuff is going on in here. We're going to walk through a few of these. So the first one is the main and the most powerful one. It's the @model directive. And this allows you to create a base type. So in this case, we have a product, and we just add this @model directive. And this will actually scaffold out an entire API for you on AWS, a scalable API, same API that these companies like Ticketmaster and Aldo are using. It's at scale, and it takes just a very little amount of code. And what we'll do is when you're using that model directive, we'll create CRUD and list schema based on the base type. So you might assume that you want to create, read, update, delete, and list products based on this type. We'll create all of those operations for you. We'll also create a product DynamoDB table. DynamoDB is the same table that Amazon uses. It's highly, highly scalable. They say infinitely scalable. We also create the GraphQL resolvers that map between the operations and the table. So all of those create, read, update, delete, and list operations are all automatically mapped for you, and we create the subscriptions for you. Subscriptions, we've seen these tested up to 10 to 50 million connected devices for a single API. So this is very highly scalable stuff. And it's all generated for you based on this one directive. Now you can add additional functionality using additional directives. So in this example, we're using the @connection directive to create a one-to-many relationship between posts and comments. So you might think of a blog, or you might even think of, I think a blog would be probably one of the most typical use cases here, or maybe actually something like Instagram or Facebook or even Twitter, when you create like a tweet and someone can comment on it. This model here is essentially all you would need. You create the association in an array. So in this case, we're saying the post has many comments, and then you just add the @comment directive, and we automatically build out the proper resolvers for you, and everything is connected, and you can begin having that relationship. And therefore, you would be able to query posts with the comments that are associated with them in a single operation. The next directive is the auth directive, and this allows you to define authorization rules. So for example, let's say you have an app and you only want the owner of the created object to be able to update, delete, or even read. You could pass this single rule, and this would only allow the owner, the person that created the post, to have access to it or update it or delete it. But more often than not, you're actually going to have the need for multiple authorization rules. For instance, when you think about Twitter, when you're signed out, you can see the posts. You can see the tweets. When you're signed in, you can see the tweets. And if you're the owner of the tweet, you can actually delete the tweet, right? So therefore, you would need to have multiple authorization rules. You could do that just by passing an array. So in this example, it would allow the owner to have full access, and it would allow public people that are not the owner to have the ability to read the posts. And you can add even more than this. This is kind of a pretty basic example. The next directive that we'll look at is the function directive. So you could create any query or mutation and map the arguments into a Lambda function. And this is running on AWS. This is true AWS Lambda. This isn't some abstraction on top of it. So it's highly scalable as well. So in this example, we have a type of query. We're just adding this new operation of add. And this is going to map the number 1 and number 2 arguments into a Lambda function. And then whatever you return from the Lambda function is the result. And in this case, it's an integer. So you might pass in like 5 and 5, and this would just return 10 or something like that. We also have an HTTP resolver, which allows you to kind of take your microservices and port them into a GraphQL schema, or just really any REST API. So if you have any HTTP API, you can just kind of port it in here. So what I would like to do in this example, in this live coding example, is rapidly prototype an API. And what I would like to do is have an API that is like a true, GraphQL API, one of the ones we would use at scale with our real customers. I want to create the schema. I want to have all of the operations defined. I want to create resolvers for all of these operations, databases, and then I want to have relationships, and I want to have author roles, and I want to test this all out. So in that case, what we're going to do is try this out. So I'm going to jump into my text editor. Actually, I'm going to jump into my CLI, and we're going to try this out. And I think I'll probably need to zoom in even a little more just to make this readable for everyone. Okay. So here I am in an Amplify project. Nothing really has happened in this project. All I've created is an authorization service. So I've run Amplify add auth. And I might just minimize this. Here we go. And what I want to do is I want to add a GraphQL API. So I'm going to run Amplify add API. And here I can choose either GraphQL or REST. So I'll choose GraphQL. I'll call this API name. I'll just take the default of GQLB, like GraphQL Bangalore. And then we can choose the authorization types for the API. Now, you can have a single authorization type, or you can have multiple. So for instance, I might want my API to by default be public, and then I might also want to allow private access for defining ownership and authorization rules. So for the default authorization type, I'll typically choose either API key or Amazon Cognito user pool. API key is public access. Cognito user pool is the managed authentication service that I've added, and it's similar to something like Auth0 or Okta if you've used that. And you can also use OpenID Connect if you would like to bring in your own authorization provider. So if you are indeed using something like Auth0 or Okta, you could just set that up using OpenID Connect. Okay, so by default, I might go ahead and choose, I guess, Amazon Cognito user pool, since I already have that added. And do I want to configure advanced settings for the API? I'll just say no. Actually, no, let's add another authorization type. So let's say yes. And for the additional authorization type, I'll make API key the second one. That way we have public and private access. I'll just give the name and the expiration for the key. If we wanted to build an offline first app, we could also configure conflict detection and conflict resolution in the resolvers. We don't really need that, so I'm just going to choose no. If I had a GraphQL schema, I could reference it here, but I don't, so I'm going to choose no. And then I can just choose any of these boilerplates. Doesn't really matter, because I'm going to be kind of updating everything anyway. And we'll go ahead and edit the schema. And by default, we get like this base to do type. Whoops. Go ahead and close this stuff since I'm not using it. We have this base to do type. And I'm just going to delete all that. But what we actually want is a type of post, maybe. And then we want to have like a type of comment. And then we're going to create the relationship between those and add some authorization rules. So for the post type, I'll have an ID. I'll have a content. And I'll have an owner. And I'll have, I guess, comments. And then for the comment, I'll have an ID, message, and an owner. The owner is just going to be the authorization field. So like we'll automatically be able to read off of the JWT who created this. The next thing we might want to do is add the relationship. So I can just add that connection here, and this is going to automatically map the relationship between comments and comments. The next thing I want to do is add @model to both of these to make sure we also get the database tables and the schema and resolvers created. And then the last thing I want to do is add some auth rules. So here I can pass in an array of rules. And each rule is going to be a map or an object. So I'm going to say I want to allow owner, first of all. This means I want the owner to be able to do everything on this post. They can create, of course, after they create, they can update, delete, or read their own posts. I'll also say allow public. We have public access, and I want to limit the operations to read. So only the person that created the post can update, but anyone can read. And then I'll also want to set specifically private access. This is going to say someone that is signed in can also read if they're not the owner. So this is kind of the type of access you would need for almost any of those types of apps I was talking about. If you wanted to build like a Twitter or an Instagram or a blog or anything like that, this base set of rules would work pretty well. And for the comments, I might do the same thing. Have allow owner, allow public, allow private. And then if you really wanted to take this even further, you might say something like allow groups. And if you want to have like an admin, you could just pass in an array here of like admin. And then this way you could also have an administrator that would have full access as well. And this can either be a hard-coded string or it could come off of the GraphQL field itself. So you could do something like this. So, you know, that's something we'll test out as well. And let's say we want to be able to have admin access, maybe also on the comments. So if someone leaves like a comment that's not nice, we'll delete it. Okay, so this is it. This is all we need. So we can go back to our command line and we can run amplify status. And we'll see that we have our API here. And we can either deploy this with amplify push, or we can actually mock this locally with amplify mock. And this is going to now read, oh, it looks like I misspelled something. Misspelled string. Let's try that again. So this, if working properly, if I didn't misspell or mess up anything else, it's going to go ahead and introspect our GraphQL schema. It's going to then automatically generate a local table for every model. So we have a post table created locally now and a comment table locally. It will also do the GraphQL code generation and JavaScript, TypeScript, or Flow. And if we were in a native project, we would have those options as well. We can choose the location for these GraphQL operations. I'll just choose the default. I'll just choose the default for everything else. They're asking things like, do we want to generate everything? Yes, usually, and the maximum statement depth. So now that we have that done, we'll be given a mocking endpoint that we can test out locally. So this is going to be kind of like a graphical editor running locally, and I'm going to test that out here. And I know I need to zoom in, so I'll go ahead and do that. And here we can test out our local environment here. Okay, so we have the ability to now like create a post, read, create comments, all that stuff. We even have the opportunity to kind of switch between authorization types, authorization modes. So, you know, what we might do, like we're signed in with API key. Let's go ahead and try to create a post. But we probably won't be able to do that because we are not signed in. So let's test that rule out though. We don't want this to work. So let's go ahead and do a mutation. We'll say that creates a post. Oops, I'm getting all of my syntax wrong today. This should be a mutation. There we go. Now our autocomplete is working. So we want to go ahead and return the owner because that's going to automatically be populated. We want to give the post, I guess, content. And that's it. The ID is going to be generated automatically, and we might want to just return some more stuff here. So let's see if this works. And it does not work because we've set an authorization rule that only signed in users can actually create. So let's now update auth and sign in as someone else. So I'll sign in as David3, generate the token. Now we're able to create a post. And then next, I'm going to go ahead and create, well, let me just copy this and create a comment. For the comments, this is going to have a message. Say, great post. I'm going to now use this post ID for a relationship. So I'm going to say, I need the post comments ID. That's going to be this ID. And we have that relationship here. And you'll also notice that the owner field came back, but we did not input that as an argument because again, we're reading off of the JWT, the ID token securely. Therefore, this, in the resolver, this is where we get that information and it's stored in the database. So if I go ahead and I create this comment, let's go ahead and sign in to someone else. Create comment. Okay, now I should be able to go ahead and query and get all of the data back in the relationships. I'll say list comments. Actually, let's say list posts so we can get everything. So for the post, we're going to have the content, the owner, and the ID, and then we'll have the comments, and we'll also have the message and the owner. So there we have that relationship is now pulling down all of the posts and the related comments. The next thing we might want to do is test out some more authorization rules. So I am signed in as Jennifer. I want to see if I can update that post to say something else. So let's do a new mutation. The ID is going to be this ID. The content is going to be like new content. And we should not be able to do this. So let's try it. And it looks like it failed because we are signed in as Jennifer. We're not signed in as Dabbit3. So let's update the auth and sign back in as Dabbit3. We should be able to do that now. So now we've updated the posts and we have that new content there. The last thing we might want to do is sign back in as Jennifer and make her an admin. And this is going to be read again off of the JWT. So I can say updated content by Jennifer. And the owner field should now read Jennifer, and this should work as well. Because actually the owner wasn't updated because we didn't change that, but we could actually update that as well if we wanted to by just passing it in. Oh, you know what? I'm not sure if this is going to work because this is, again, read off of the JW2, so this isn't going to work. We would have to create some custom logic there because the person that created this post, we can't really change that unless we specify that in the resolver. And that makes sense because we wouldn't want to really change who created something unless it was some use case that wasn't typically supported. But that's it. So we have all the auth rules, all that stuff is working. If I go back and sign in with API key, I should also be able to list posts because we have the authorization rule set to public, right? So anyone reading the app can do it. So we've now built out something that's pretty solid, and we've done so in just a few minutes. And this is the type of app that again would scale, in a real world situation. The last thing I'll do is kind of go over one of the examples that I've tried out at a massive scale. And this is a voting app, and I have a schema that looks something like this. I have a type of poll and a type of candidate. The only custom GraphQL schema I've created is a mutation of upvote. and the upvote does an atomic update on the database. So we're basically going to be incrementing, regardless of what the current value is. We just want to increment by 1. So therefore, we're not going to be using any existing values that we have out external to the data. We want to increment, and to do that, I wrote a single custom resolver. But what we've done to test this out, you can actually go to and test this out live with me. This or that.cloud. I've created a poll because I'm a huge fan of Indian food, and I just actually cooked my first meal this week at home because I haven't been traveling, and I live in Mississippi, and there is no good Indian food here. So I had to take it into my own hands and make some food at home. But let's say we open this window, and let's say we make some updates. Everything should be coming through in real time. Like if I start uploading this, you start seeing it going up. And then if you kind of drill in, you should be able to see kind of a live update of like what's going on. So if anyone wants to go to this or that.cloud and test this out, feel free to kind of try to bash on it. What I did to test this thing at scale is I set up like a function that basically hit this endpoint over 1 million times within 1 minute. And not only did it scale the database on the database end, but the client actually came through in real time. It looks like, see, I'm not touching it. Some people are updating it, which is good. But anyway, so yeah, I basically hit this database with over 1 million updates in about a 1 minute time period, and it scaled perfectly. It was crazy. And from doing some additional digging into DynamoDB, I've understood that there have been situations and use cases where customers have used DynamoDB at scale with over 1 trillion updates within a 24-hour period, and it's scaled as well. So it is a massively scalable database, and the fact that it's so easy to kind of get going with, to me, is like super powerful. And it's really, it's really one of the cool things about cloud computing, and one of the reasons that I'm really interested in this space. And that's it. So I just wanted to say thank you for coming to my talk. And I'm Dabbit3 on Twitter. If you're not following me already, feel free to follow me and ask me any questions. And that's it for me. I'm going to go ahead and stop sharing my screen.
Awesome. That was an interesting talk, Benita. Yeah, you would like basically coded up a GraphQL schema and then added some mutations and queries out of the box. And yeah, the app was built pretty quickly. So we have a few questions, Nida.
Sure.
So I'm just going to put this first question. So Rangasamy asks, is Amplify a Node.js library?
Yeah, so there are a couple of different Amplify libraries for different clients. And we just actually updated the Amplify JavaScript library to run on Node.js, like server-side rendering SSR support. So it's just a JavaScript library, but it does run on the server in a Node.js environment.
Great. We have Praveen asking how to transform existing REST application to GraphQL.
Yeah, so one of the biggest things that we've noticed, with all of our customers that are interested in GraphQL is that they have that exact question. So we've actually added a couple of improvements, and I think it just depends on your environment. Like if you're building your own GraphQL server from scratch, you'll probably just create operations in your schema for porting over existing REST APIs into your existing schema, and then you might port over each individual REST API individually. And you would have to rewrite, that logic on for that API at some point. And that's kind of what we see as well. But with AppSync, we have a couple of different ways to do that. First of all, you can use an HTTP resolver, which will just map the request into an HTTP endpoint. That way you can just port it over right away. And then if you want to rewrite that, you would then just have to kind of port over whatever. You have to create new types for the data that's coming back, create new operations to interact with that data. And then once you had everything working, you would just stop using the old REST endpoint. And then the third way is using a Lambda function to kind of talk to an API. So if you need some really complex logic or transformations that happen between the request operation and when you talk to the API, you could just map over the arguments into a Lambda function, call the Lambda function. Call the API from the Lambda function, return the response in the Lambda function back to the GraphQL operation, and AppSync again handles all that. But if you write if you write your server from scratch, you could do that in an Apollo, environment or whatever server you're using at the resolver level. I'm sure all these other, options out there. I think Hasura has a way to use Lambda functions as well. That you would probably do it in some type of either HTTP resolver or a Lambda function. And then you would probably have to rewrite the API at some point if you want to truly do GraphQL.
Yeah, I think as you mentioned, I think I just want to add something. Basically, typically your application will probably be an existing REST API, and your organization or your startup just wants to incrementally adopt to GraphQL. So it's basically like writing your GraphQL types and then mapping to a HTTP resolver or your Lambda function, and then incrementally move towards your migration to a full-fledged GraphQL server. So, and I think all of the options out there, including Amplify, AppSync, and Hasura, and everybody lets you do this in a way in multiple options, right? So that's great. I think we have probably not a question. I think Parth Kanani asked if you code in TypeScript.
Can you code the apps in TypeScript?
I believe so.
Yes. Yeah. So we generate we do code generation in TypeScript. So yeah, absolutely. And in the future, we're going to be creating an option for TypeScript resolvers. So you don't have to write your resolver code in the native language that we have right now, which is VTL. You could write JavaScript or TypeScript. And we also just released support for direct Lambda resolvers. So you can map the operation directly into a Lambda function without any, there's no AppSync resolver other than the Lambda function. So there's no additional complexity. It's pretty straightforward.
Right. I think that's mostly it on the Q&A, on the comments. If there are any more, I think you can probably asynchronously catch up on the GraphQL Slack channel. There's a GraphQL Bangalore channel on that Slack, and any more questions can be taken up asynchronously. But just to add to one of your points where you mentioned Harry Wolf's tweet about why he's not using GraphQL anymore because of the complexity involved in the servers. I believe all of these services which gives you managed GraphQL, auto-generating your resolvers technically, that takes care of the complexity that actually prohibits people to start trying on GraphQL. So I think it's great that these solutions give you a solution which takes away 80% of your boilerplate work, and obviously there'll be 20% of custom business logic and so on, where you will have to write your custom code in the language of choice. And yeah, so it's interesting to see these solutions evolving on a daily basis. And yeah, right. So yeah, that's it for the first talk, I believe. Thanks, Nida. Thanks for this awesome talk. Always a pleasure to have you on stream, and hope to see you on a different stream, different time. Yeah, until then, thanks for coming on the stream.
Yeah, absolutely. Thank you for having me. I hope everyone has a great evening.
Awesome. Right. So I'm going to add the next speaker, Ashwin. Hi, Ashwin.
Hey, Praveen. How's it going?
Yeah. Yeah. So Nida just finished his first talk. It's pretty good. Yeah. How's it going on your end?
All good. All good. Working from home, liking it. I like work from home, so this is comfort zone for me.
Wow, that's amazing. Yeah. All right. So I believe you're going to give a talk about using GraphQL in a Flutter kind of an app, probably like a chat app.
Yes.
And yeah, hopefully you can like probably like show some code snippets as well on the slides. Yeah. So yeah, I'm gonna add your presentation. So over to you, Ashwin.
Yeah, thanks, Praveen. So yeah, we're going to build a chat application today, and we're going to focus on the aspects of scaling a chat application using GraphQL and Flutter. We use Hasura to run our GraphQL engine. I'll get into that. But first, I want to thank Vivek, Vikesh, and Akash, the first three people on screen who helped me set up this presentation. So, all four of us are a part of the initiative that we ideas within Swiggy basically means that ideas that we feel will have a major impact on the bottom line of the company in the future. And because we are an independent sort of unit inside the company, we get to make our own technology choices because we don't have to worry about what is already out there in, let's say, the Swiggy app, right? We can use technologies that are a bit newer if they solve our problems better. And what we will be talking about today is how to manage, GraphQL permissions for soft deleted data. Soft deleted basically means that it's the user perceptibly feels that it's deleted, but it's not actually deleted from the server. There can be many use cases for this. Like in e-commerce, for example, when you delete an item, that doesn't mean that the orders that have already been placed can be deleted, right? So we're going to talk a bit about that. But the focus of the talk will be on scaling chat applications, right? We had to build chat for one of our applications, and it was a core part of the user experience. And we wanted it to scale infinitely, right? And we did not, the number one constraint for us that we did not want to make a local database, right? Like WhatsApp, for example, has a SQLite database within the application. And we felt like the migrations and everything would be too difficult for us to manage, considering in new initiatives, we like to move fast. We like to build applications quickly, test them out in the market, and get feedback. We like Flutter because it lets us build UI a lot faster. We've tried React, we've tried other technologies, but Flutter is the thing that's worked well for us. And within Flutter, we're going to talk a little bit about how to manage state of the application. As you know, there's API endpoints loading, your subscriptions are on for your chat messages, your updates are coming in, etc. Right? What we won't be talking about though is user interface. There are a lot of open source libraries that you can find on pub.dev for chat UI if you're looking for inspiration. Authentication is a whole another topic. You can find a lot of documentation on Hasura if that's what you're using. And regarding the GraphQL server, if nothing else, you can use Nader's solution to set up a GraphQL server. We are going to be using Hasura personally, right? So this is going to be our stack, just Hasura running our GraphQL engine, and all our dev will be in Flutter. We will use no other technology. So first, I'll talk about the schema. We're going to make a simple chat application. So we need a users table. I'll do a bit of commentary on every table so that you have some context as to what's going on. In the users table, the ID column is going to be a UUID. Generally, by default, most people make sequential IDs, integers, right? The problem we saw is that kind of lets you deduce the number of users in the system, right? Because they generally increment sequentially. So we use UUIDs. And Hasura, in this case, provides nice shortcuts for adding the created at and updated at column to every table. They are super important for what we will do later in this talk. We need the created at and updated at to know when a particular row inside a table has been changed and when it was created. And then we have a name column to save the user's identity. Second, we have the groups. These are actually the groups that we're creating, the WhatsApp groups. Very similar to the users table, we have the ID created at, updated at. One extra column we've created is the preview column. So if you notice in WhatsApp groups, below the name of every group, there is the last message, right? The last message received in the group. So preview is where we will hold this last message. There are multiple ways of showing the preview, right? One thing we could have done is run a query in real time. But if you're trying to scale an application, the best thing you can do is cache values that will be accessed frequently. So in this case, because the group list will be activated, accessed multiple times, we want the preview to be saved in the group table itself. Every time the message updates, the preview will also update. Third, we have the participants table. This is basically every group can have a number of participants, which are users. So this is a connecting table between users and groups. While it's not in the focus of this talk, here is this table is where you would probably save stuff like who is online, when they were last seen, who is an admin, who is not. If someone is typing, you would probably create a flag here for saying that they are typing. Last is we have the messages table, right? Very simple table. Again, a user is going to post a message inside a group. There will be a body for that message. And we've created an archived at column. This basically means that the message has been perceptibly deleted by the user. This is important. We need to save the fact that it's archived so that the message is no longer accessible. When you delete a message on WhatsApp, for example, it removes the normal body of the message and instead it says that the message has been deleted. We're trying to replicate something like that in our table. Now we will have to create a couple of SQL functions. This can be translated into whatever database provider you're using. There's going to be 3 of them. The first one is called scrubbed body, right? Now we have a body column inside the messages table that stores the text that was actually sent by the user. But if the user has deleted the message or archived the message in our case, we don't want to return the body. We want to return the text that this message has been deleted. So that's all this function does. It creates a computed column in Postgres. So it's not actually physically persisted, but every time I call it, this small piece of select code runs and it returns the body. Next is we have a function called groups preview. As I mentioned earlier, every time a message updates, right? A new message is inserted or updated in the messages table. We will set the group preview to the text of the last message. Here we're using scrubbed body instead of body because it could be that the last message sent in that group has been deleted. Don't worry about the code snippet. This is open source. There's a code repository at the end. You can go check it out yourself as well. We have another function for updating the group's timestamp. This is basically every time anything inside a group updates that would warrant an update of the group, you will want to set the updated at of the group, right? So in this case, every time a new participant joins, basically after insert on participants, we want to say that something in the group is updated. Please go fetch the group again. So that's all this function does, is that every time an insert happens, it just tells the group that something is updated. Right. So now we're going to dive into a bit of GraphQL, the fun part, right? So a few facts about GraphQL subscriptions. First is that GraphQL subscriptions have a polling rate. It's not completely real time. So in Hasura's case, for example, it defaults to 1 second. That means that all the updates that have happened in 1 second are sent together. And in Hasura, you can actually tweak this value by setting this environment variable you see on the screen. But because there is a polling rate, it means that if, let's say, a series of writes happen in quick succession, like 5 people send a message in 1 second, only the last message, as in all of these will be bunched together and sent as one subscription update, right? Which means that GraphQL subscriptions are not event-driven, right? It's possible for individual writes to be missed, especially if you're subscribing to, let's say, the most updated message. You might actually miss the 4 messages that were also sent in that 1 second window. Now, one workaround, a simple workaround, is to reduce this 1000 millisecond number to something as low as 100. But you're putting a lot of stress on your server, especially if your subscriptions are complicated. Now, another thing we found is that subscriptions scale poorly, especially if you are subscribing to complex data structures. So if you're subscribing to, let's say, 4 nested joins and you're going deeper and deeper, you're loading the posts and the comments and the users of those comments, and you're loading all that data. It's especially heavy on the CPU. So that is something we want to avoid. We want to use subscriptions sparingly so that the stress on the server is as minimal as possible. Now, the problem, the way we're going to solve it is that we will have some local data, right? So this is the data that's already been loaded in our phone, saying that we have 2 messages, one at time 1 and time 2. And remote is basically the server where 2 new messages have popped up, right? Someone has sent a message, or maybe it's just someone has updated or deleted their previous message. But basically 2 changes have happened since my local data was loaded. Now, what we want to do is we want to basically say that if the local maxima, right, which is the last update is at time 2, is less than the remote maxima, which is 4 in this case, we want to sync just enough data to make the local maxima reach remote maxima. Basically, what it means is that we want these 2 messages, right? We want these 2 updates. and we want to spend as little resources as possible to get these 2 messages. So we're going to have, we'll talk about first the list of groups, right? As soon as you open the app in WhatsApp, for example, first you see a list of chats. And then when you click on a chat, you see the messages. So here we're talking about that list of chats, or in our case, the list of groups, right? So we have a query on the left. So as soon as the app opens for the first time, we are actually going to run a query. This query just takes one variable that says since, right? Since is basically saying that I want all the updates since a particular time. And the second one is a subscription that will keep me updated about the last time for, right, this number, saying that what is the last update in the groups table, right? Now, because we limit the subscription to just one row, and even within that row, we're only running the subscription on one column, this is incredibly efficient, right? You could probably run millions of these without a hitch. And now we're going to jump into a bit of Flutter code. So this is a complete parallel to what we just saw. This is the query and subscription, and this is the query and subscription running inside Flutter, right? So what we will do is that, let's say today is the 27th of August. We're going to first run a query that gets all the groups for from the day this app got launched, let's say, right? Because we just loaded the app, there is absolutely no data in the app. It's a blank slate. So we want to get all the groups that have been created since the beginning of time, right? And the fold function in Flutter lets us compress this list of groups into one value. Basically, what we want is the maximum updated at of the local data. So we save it in local maxima, right? This basically will tell us, after running this get groups query, what is the maximum updated at in my local data, right? And then as soon as this query is done, we're going to run a subscription saying that I also want access to the remote maxima, because at the time of running this query, both of these will be the same. But as updates keep coming, the remote maxima will keep changing, right? And then we run a simple if condition saying that if the local maxima is before the remote maxima, I want to load all the messages or all the groups in this case since the local maxima, right? Basically the window that we talked about here, right? We want to get as much data as possible to go from local data to remote data. Something similar will happen in the case of messages. So this is after you open the chat window. The only difference is that we've added another variable here called group ID, right? Because when you open a chat, you're going to be looking at the messages for a particular chat. So the first time you open that chat, we're going to run a query saying that give me all messages since the group has been created. And after that, I'm going to subscribe to the remote maxima saying that give me the last updated message in that group. Very similar Flutter queries, right? As soon as the app first loads, we're going to get messages for that group. And then we're going to run a query saying that I want to know the remote maxima, right? Every time something updates on the server, I want to be informed so that I can run a query to update my messages. Now, so this basically makes it very simple. When the app first loads, right, you're going to basically say, I want to load all the groups from the date the app was launched. And after that, you're going to run a subsequent, you're going to subscribe to this value saying that I then want to load only the updates. And message is going to be something similar, saying that on the first load, we want to load all the messages. And say after that, we only want to load the changes that have happened. Now, we've tested this out in our production applications, and something like this, this combination of just getting your local maxima and then getting the updates since that local maxima works really well, because queries are incredibly efficient. Because queries are transactional, you run the query and the resources are freed up, as opposed to subscriptions which keep polling as long as the app is open, right? So in our case, because our subscription is limited to one column and one value within that table, right? We can honestly, there's no foreseeable limit we faced with running subscriptions like this. So you could actually run this on an AWS free tier and still be able to scale to hundreds of thousands of users, right? Same thing with messages. Now, because we've split out our subscriptions for groups and messages into two, if the messages window is not open, the messages subscription is not running. That means that if you could have 1,000 groups on your home screen, but the subscription for the messages will only start once you open the app. But because we run a query as soon as the chat window opens, the user will not feel the difference. The user will not feel like, hey, I had to wait for a subscription to connect before seeing the messages. So what we've done for your benefit is that we've created a simple repo where all the code that I've showed, some of these are snippets and non-actual code. You can actually find all that code on revit.com/chatty. It's open source. All you have to do is download the code and make a release build or whatever dev build, and it will start working. And yeah, that's the core of my experience. Now, I'll just a bit of background is that we are using this in a production application where chat is heavily used with groups being as large as 5,000 people, right? And even with 5,000 people, we found that this experience is able to scale even on the free tier of AWS. So you could extrapolate this to add a lot more features. In fact, in the public repo that is on the screen, we've built out a couple of more features, like being able to select multiple messages, delete them, copy them, etc. Some of the features that you may be used to with WhatsApp. I think it should serve as a good base if you're looking to either make a chat application standalone or trying to integrate chat into an existing application. Also, if you have any questions, feel free, but we're also hiring inside the Swiggy team. So if you are a Flutter expert or you want to learn Flutter, you like GraphQL, I think you'd really like working with us. So send me an email at ashwin.goel@swiggy.in. Awesome.
Great, great, Ashwin. That was a great talk. Interesting to see Flutter being used in a production app with GraphQL, and just personally curious from my side, how is the client tooling around Flutter for GraphQL and the caching ecosystem and so on?
So we actually use a public library called Hasura Connect, which lets us run queries and subscriptions quite simply. But I think even outside of Hasura, there is a lot of tooling already built out in Flutter. In fact, that's one of the things we like about Flutter is that a lot of the tooling comes built in, right? Like we don't have to make every widget ourselves. And because it comes from Google, we don't even have to go through a decision-making process. When we were trying to use React Native, one of the concerns for us was that with every small feature, we had to make a dozen decisions, right? Hey, do we use this library over that? Do we use this list view or that list view? Whereas in Flutter, because like a lot of the components come built into Flutter, that decision-making process is a lot simpler. That means that our applications are getting built faster. In fact, our last production application went from idea to launch in like 30 days, which for a company of our size is a huge, huge achievement.
Yeah, totally. So, because I was specifically asking this because for React or for Vue, like you have a multitude of libraries. For example, you have Urkel, you have all of these GraphQL, Less, and so on. So, for Flutter, I believe there are a couple of libraries, I suppose. And like, is it mature enough to be used in a production app?
Oh, for sure. In fact, we even gave a talk with some of the people at Flutter team. We've spoken to the Flutter team as well, and we definitely feel like Flutter is the future of cross-platform mobile development. If you are starting an app today and you want that app to be available on Play Store, Android, web, etc., I think you will be doing yourself a disservice by using a non-Flutter platform. And in fact, I would personally recommend Hasura as well. Is because speed is the number one thing that makes or breaks products these days. It's not that you will have the best product, as in, your UI UX is not going to save you. What will save you is that if you release your app as soon as possible and then respond in real time to changing market dynamics. And the best way to do that is for your technology to support you rather than stand in your way, right? So that is why we like technologies like Hasura and Flutter, which kind of let us go from idea to execution without having to worry about what's happening behind the scenes in many cases. So yeah, definitely recommend both of these technologies.
So Ashwin had just one last question. I know it's a GraphQL meetup, but this is something around Flutter to say. Did you, in this journey, did you ever feel like maybe there is something which the Flutter experience or the Flutter dev experience is lacking compared to native experience, and you wish like, maybe Flutter could have been on par with the native experience?
I think in some cases you run into not problems per se, but like a few limitations. For example, a lot of the SDKs that are available in the market, right? Let's say in our case, we were trying to integrate the Truecaller login system, right? Now, Truecaller only provides native SDKs. So we have to write a bridge between Flutter and native to make them work. Aside from these native bridges, I don't think we've run into too many problems with building out a production application in Flutter. Yeah, and in fact, I would say that because so I'm not a mobile developer, but I've become one in the past 45 days, right? Now, I don't know the ins and outs of performance on Android and iOS. So if you ask me to code a native application, while I'm sure that, the best native programmers could probably write an application that's better than Flutter, I'm not the best native developer, right? So Flutter gives me a reasonable default to the place where, even a non-experienced person can create production applications that are on par with something like, let's say, Swiggy, right? Without having to truly understand the underlying architecture of how screens are rendered, etc. Right? So I think that empowering that small team of developers or the individual developer is what really drives it home for us for Flutter.
Right. I guess being able to go from idea to production just in 30 days tells the story of all the stack choices you made.
Yes, I'll give you a comparative example as well. In the past, when we tried to do some of these new initiatives, it's taken somewhere between 6 to 9 months to agree on a design, and then maybe 10 or 11 months to go from design to an app in the market, right? Because we have to build apps that scale from day one. And if bringing that 20 months down to 1 month is feasible, then it makes us a lot more nimble as an organization, especially as the organization increases in size, right? You have a lot of legacy data you have to support. If you can still, despite that, launch an app in 1 month, then I think our chances of remaining dominant in the industries we serve are much higher.
Right. Just one last quick question. So in your stack, there was no managed service, right? Everything you used was open source.
Yeah.
And you guys hosted it yourselves.
Yeah. So in fact, this entire demo, that application, you can actually run it, was coded in, I don't know, about 2 hours, right? So in our case, we had some reference code to pull off of as well. But it really speaks about how quickly you can go from nothing to not just with Hasura, at least in this case, an incredibly scalable server, but also with Flutter, an incredible native-like app experience. And you can actually build out the open source code we sent on iOS as well, right? So you have a cross-platform application on day one. In the past, I think it was common knowledge that in startups you always start with Android, because Indian market is like 90% Android, and you will always eventually get to iOS and release for them. But what we saw is when we launch a product, those 10% users are very vocal, right? So if it happens to be any app that requires cross communication between people, right? Any communication angle, chat angle, etc., right? If you can't bring those 10% users online, then those 90% will also leave, right? Because those 10% users are very vocal. So I think considering the demands of the market that you have to release a cross-platform scalable app on day one, I think this is the right set of technologies to choose.
Great. Thanks, Ashwin. I think it's been pretty insightful. We don't hear a lot of stories around people using GraphQL and Flutter at scale.
Yeah.
Okay. So I think, do we have any questions on the chat? I don't see any, which marks, I guess, probably the end of our meetup. Should we just give a closing note?
Yes, I think, thanks, Ashwin, again. It was a pleasure having you to the stream. It's pretty interesting to know that Flutter and GraphQL is being used in like large-scale applications in Swiggy. It just gives a lot of confidence for newbies to start using Flutter and GraphQL, so that you know that this scales, this kind of technology combination scales from day one for you, so you can focus on building your actual logic of the app and not worry about the technology choices.
100%.
Great. Awesome. So I think we've now come to the end of the meetup. I'm just sharing our Twitter handle and the Slack channel where you can join us again. You can follow us on Twitter. I think we're planning our next meetup for the last week of September. We'll announce the dates probably tomorrow, and then you can, like, if you want to give a talk, you can submit a CFP, and hope to see new people coming in and sharing their experience with GraphQL. So yeah, Karthik, do you have anything to
Yeah.
add?
Yeah, I guess thanks everyone for joining in, for our first ever online edition of the GraphQL Bangalore Meetup. And follow us on, I think Twitter is probably the best ways, best place to get all the updates around the meetup and the schedule. And if please do not hesitate to submit CFP. Please shoot all the ideas you've got. We love to have you on our meetup and understand your use cases and your stories around GraphQL. So I guess see you all soon. I guess in our upcoming meetup. Until then, happy coding.
Yeah. Thanks everyone. That's goodbye from us.